remote access. In this nugget, we'll be discussing remote access. We start off by talking about network access protection, which is a great way to make sure that if you've been out of the office for a while, for example, with your laptop, that when you come back in with it, that it has not picked up any viruses that might be a threat to the rest of the network, or any other kinds of threats. We also take a look here at dial-up connections, a very brief look, because this is kind of an old, antiquated way of making connections. Hopefully you don't have to do those too much anymore. A more current way to work is with a VPN, or a virtual private network. And because of the proliferation and availability of the internet, you'll see this much more frequently. A type of VPN is something called direct access, which will make a connection for you automatically over an IP version 6 network. Also, we'll take a look here at remote desktop services, which is a terrific way to give yourself a fully available and functional desktop. And at the same time, you can also provide for yourself just applications if you need those for your users, but without providing for them an entire desktop. And that uses a new feature called Remote App. Alright, let's take a look at something called Network Access Protection, which on the exam objectives is called NAP Quarantine Remediation. Okay, so first of all, what's NAP? NAP is Network Access Protection. And this really relates to vulnerable hosts that could come into your network. I mean, I'm assuming that most corporations will have some kind of antivirus solution. It's probably centrally organized from an antivirus server that sends the updates out to the clients, make sure that they always stay updated. They probably also have WSUS or some third-party product, which likewise will issue Microsoft updates for everything from the operating system to Microsoft Office to some of the various types of servers, such as System Center Security, System Center Configuration Manager. So all of those kinds of updates can go out to help keep your clients not only secure, but also stable and hopefully more protected against bug fixes and threats like that. Well, it could be that you might have somebody who's been out of the office for a while, so that when the antivirus server sent out its last update, they weren't even there to get the update. So now when they come into the network, after having been to a lot of different airport Wi-Fis and hotel Wi-Fis and things like this, they may have picked up a virus or some kind of a security threat, and now as soon as they get onto your wireless network or plug into your wired network, either one, they could transmit that virus in moments. So that's an issue. We got to be concerned about the possibility of a single vulnerable host. This is going to be something that could potentially threaten the entire network, and as you see in the example there, it could have been a laptop user that was out. It could be a guest. Maybe a guest with a laptop comes into your organization, and maybe they just decided to plug or to connect to your Wi-Fi. And even if you have something like a VLAN, which is a virtual local area network, that's specifically segmented off for guests and it's like a low-threat environment, there are still hacks and things that could get even into that and still potentially breach any other security vulnerabilities or security measures that you may have taken. Likewise, the guest might even be on somebody's computer that is fully protected in your environment, but they might be using remote desktop to connect to one of their machines back in their office. Well, maybe they don't have the same high security standards you do, and that remote desktop machine has some security vulnerabilities, which could get transmitted over the remote desktop connection. Or they check their email back in the office and download a bad attachment from it. So there's lots of different things there, and some of those things are not vulnerabilities only of guests, but even of your own users. I mean, your own users can also download email attachments that are malicious. It can also be a home user, such as a telecommuter. Once again, if they connect using a virtual private network, which we'll also talk about here before long, then this means that even though they're sitting at home, they are really pretty much on your corporate network as if they were in a cubicle in the building, in the office building. And so if they, again, have any viruses on their machines or any other types of threats like this, then again, it could get into your network from their home. So let's take a look at what we can do about this. And now when it comes time to detect any potential threats, like you have an unprotected host, for example, you want to be able to detect that automatically, because there's not an administrator that can really practically inspect every computer that comes onto the network. So that has to be pretty automatic. And you also want to remediate it, again, as automatic as possible. Doesn't have to be in this case, but as much as you can. This will hopefully require little or no user action. There are certain things, such as if they don't have the firewall turned on. That if you automatically remediate that, well, maybe it could automatically turn that firewall on. Or automatic remediation may also automatically download any updates from a Windows Server Update Services server. You can also configure NAP so that it includes a link to an intranet web page, and maybe that web page will point the user to your antivirus update server, the WSUS, or maybe there will be a link on there that launches a script that launches a update check or something like this. So, there could be some automation involved in that, although you can also make it manual if you want the user to manually check for updates. There's also a restricted network involved in this. I mean, how are they going to get their updates if you don't let them connect to the network at all? You can't really do that. You have to at least let them get onto what we call a restricted network or a remediation network or a remediation server. They're all kind of the same idea. But it's one or more servers that are specially designed to let the client come back into a healthy state. And there's something called a health check that takes place with this. And then once they're healthy, maybe they got the firewall turned on and their updates downloaded and all, then they'll be able to get access to the full network. Now, some of the updates and all may still require the user to restart the computer or something like that. So some of this may involve a little bit of user education. And again, maybe that could take place through the web page that you create for this. But for the most part, it should be as automatic as you can, just for simplicity's sake. Now, as an example of this, let's say we've got, again, our laptop user that comes into the network after they've been gone for a long time, and maybe they missed some updates. Well, if they missed some updates, then they'll fail the health check. And what will happen then is that they will not be allowed into the main private network here, where I've got all my protected resources like file and print servers. Instead, what will happen is the Active Directory domain controller in their remediation network will go ahead and authenticate their credentials. They'll need to, of course, also first have gotten an IP address from a DHCP server so that they can at least communicate on the network. And then when it's found out that they don't have the latest Windows updates, then it'll potentially send them to the WSUS server to automatically download those updates. And then once that takes place, a couple other things can happen now. Once that takes place and they are now healthy, then they will have a health check take place again. It'll be known that they are now satisfying the health requirements, and they're back on the private network the same as they probably always were in the past. Another situation that could happen with this is that if I'm not a domain client, so I don't have an account in Active Directory, maybe I'm just a guest, a traveling salesperson that's coming into the office to sell you some kind of a cute little gadget or something like that. Well, if we're gracious enough to let you connect to the network so you can get on our guest network and maybe check your email or something like that, well, we're not going to send you over here because what's the point? You can't authenticate anyway, and you're not part of our WSUS infrastructure. You're not one of our clients. So, but at the same time, we want you to be able to make some kind of connection so you can check your email and whatnot. So we have a DHCP server in another guest network over here, and it'll also have a web proxy, which probably, of course, would go out here to the internet where you can check your email or, browse the internet or shop at Amazon.com or whatever else it is that you want to do. This could also happen if maybe this is one of your own laptops. The company owns the laptop, and you administer it and all of that kind of stuff, but it's not a Windows laptop. If it's something like a Linux laptop, or in certain cases maybe a Mac, then you're not really going to be able to participate in some of these things, like the Windows updates. Mac users say that Macintosh doesn't need any security updates anyway, which is not true, by the way. They do. But if they can't participate in any of this, then they may again get put off into the guest network. So in terms of remediating those clients, what kinds of things can we do there? Well, we're going to have to, first of all, again, confirm the client does comply, and that's going to be using a health check, and it's going to happen prior to unrestricted access. That's where they're able to get to that other part of the network that I talked to you about here, if I can get to the right page. There we go. This private network up here. So once the health check passes, then they're able to get up into that. Now, the criteria that you can use for this is the following. Do they have antivirus or anti-spyware products installed? And you can selectively allow or disallow any one of these as you like. Do they have the firewall turned on? Are they participating in automatic updates? And are they actually updated in any of that? Like, do they have the current Windows updates? And if they're a little bit stale on getting those updates, then we can update those. Are they current on the antivirus and anti-spyware updates? And again, if they're stale, we can update them in the remediation process. Now, there's a lot of different enforcement types, too. What happens here is you have to determine what kind of network access that you want to protect and what kind of network access the user will attempt to access. So there's a variety of enforcement types that will line up with that. So if I have maybe a home user that creates a VPN connection into my network every day, well, I can set up a VPN enforcement type so that anytime someone tries to connect using a VPN, the VPN service will check with the network access protection infrastructure to determine if they're healthy and if they're not, how to remediate it. Same with DHCP. The client wants a DHCP address from the DHCP server, but we're not going to give them an address that will put them into the public network until that's been checked out. IPsec is a highly secure way of securing network traffic, and it involves certificates and encryption and all kinds of things like this. Well, that would be another thing that we might want to protect before we let the client on. And then 802.1x, which is kind of similar because it also uses certificates, is another way of securing traffic over the wire. It's not strictly a wireless. Sometimes people think it relates only to wireless networks. It's also a wired network security method, however. So here I have a remediation server, which I just installed this morning because I wanted to have one that I could demonstrate for you. And so we've got some things that are in place on this. Now, first of all, we'll see here that it's a DHCP server, and I've got a scope set up for this, which, as you can see, if I go to the properties, is set up for 210 through 254. And I made it a real short lease duration, only for demonstration purposes in our case. Normally, that's going to be 8 hours. There's also a network access protection tab here, and this is new with Windows Server 2008. This kind of NAP quarantine idea is something that Microsoft came up with in previous editions of Windows Server 2003, in fact. But the thing is, it was very, very complicated and involved a big, long white paper that you'd have to read and study in order to make it work. And there was no network access protection tab here. You'd have to do a lot of stuff manually to make it work. In fact, I'm wondering if anybody got it to work except for Microsoft. Anyway, what we have now is an interface to help us out with this, so we can enable network access protection for that scope, so that if anybody wants an IP address out of this scope, they have to first pass the health check. Now, the enablement of NAP restrictions is something there that I normally don't do. Even though I showed it to you first, I usually turn that on last, because we have to first configure a few other things in order to make them work, including these things. So what we'll do is we'll install Network Policy and Access Services on the server. And then once you've done that, there'll be a couple of wizards you can go through. But you can, for example, click on Network Access Protection and click Configure System Health Validators. And then there's a Windows Security Health Validator, and you can go through various settings and all with this. Actually, the first time you go through this, there'll be a different link right here, which will start a wizard that'll help you to start going through all of this. But if we take a look at the System Health Validators, or SHVs, the validator here in the default configuration is what? Well, we are saying to our clients, we want to make sure that you have the firewall enabled for all network connections. And if you fail to meet that, then we're going to put you into the remediation network. Or we will, if we choose to do so, we will also then automatically configure it so that it will fix itself. Okay, so we'll forcibly turn on the firewall for you. That could also be somewhat mitigated by something like a group policy object, which could also forcibly turn on that firewall. And then moving on here, you'll also see that if we go up to our network policies, then you'll see that there's a DHCP compliant. In other words, they meet all the rules so that they're able to get onto the network. Non-compliant, which is going to put them off into a restricted network. And then non-capable, which would put them into a guest network in many cases. So if they're not compliant, in other words, if they don't have their firewall turned on, then we'll enable this policy and grant them access. But you're saying, hey, wait a minute, I thought we were supposed to deny them access. No, we are going to grant them access. It's just that we're going to grant them access to a restricted network, which you'll find under the settings here for NAP enforcement. And it says allow limited access. And then this is also what I was telling you earlier. You can enable auto remediation of client computers, so that if they need to get an update or turn on a setting or something like that, that's what you can do by checking that box. I'm going to cancel out of this for the time being, and also show you what it would do in terms of getting you remediation. You set up these remediation server groups and you just arbitrarily name whatever you want it to be. I send my clients only to this one server. Maybe it's my antivirus server. Maybe it's my Windows Server Update Services server, or whatever. But this is the server that will fix the computer, so to speak, so that it's updated as necessary. All right? So that kind of gives you a starting point, at least, on understanding how NAP works and how it's configured on a server side. But although, again, you don't need to memorize all of those, I just at least want to give you the broad scope there of the items that are in place that make that happen. Oh, and there is another thing, actually, I do need to show you. So let me go down here to features. Actually, it's on my server. Okay, so anyway, here we are. You also create these NAP enforcement policy, and you don't have to call it that, but it's whatever policy name you want for it. It just seems to make sense to be intuitive with it. When you go into policies for this, you need to configure this for your clients that you want to receive these NAP restrictions. So to do that, I'll go into the Windows settings, security settings, and then if this ever stops hourglassing me, I'll show you the rest of it. Here we would go down to, I wish they would alphabetize this list, network access protection, and then you can see here that I've enforced the DHCP quarantine enforcement client, or I will anyway. So I'll double click on this and then I'll enable that enforcement client. Likewise, I'll go up here to System Services and we'll go down to Network Access Protection here as a service as well. And you can see that if I double click on this, that I've already set this up to automatically start on the client side. And because of that, now when the client starts up, it'll run this service. It'll know that it's enforcing, subject to enforcement for DHCP quarantine enforcement as a client. And then it's going to be subject to our rules for NAP enforcement. All right, here I've gone to a Windows 7 Enterprise computer, and you can see here that I've turned off all firewall settings manually so that I'm not in compliance anymore. As a result of that, if I do an IP config, and I did a release, and this you can see what I did. IP config release, so any IP configuration it had, I got rid of it. I renewed, and then when I renewed, it should have checked my NAP settings, my health settings, and then identified that it was not in compliance and put me into a restricted network. And I did an IP config all to show us all the settings. So here's all of the settings that we can then identify. You can see here that I've gotten an IP address of 10.10.10.210. That doesn't look so bad, right? But look at the subnet mask. That's all 255s. Normally it's 255.255.255.0. So that doesn't look right. And then it says that my DHCP server, that's right as well. Let's take a look at what all this means. When I do a route print, this shows me what my route table is and how I'm going to be able to get from point A to point B, so to speak. Normally what we would see here is a network destination of all zeros here, and then it would show me a link or a gateway of how to get there. Show me my default gateway, for example. Well, in this case, it's just telling me that if I want to get to anything, the only host I can communicate is .70. And with this subnet mask, there's no equivocation about that. It's only a single host. Same as .71. This is my NAP server, and then this .70 is my remediation server. And I'm pretty well locked out of everything else here as well. So that's what the route print item there is showing me, because I was not in compliance with the NAP policy. Another way that a client could make a connection to the network would be by using a dial-up connection. Now, these are very, very primitive and slow comparatively. I mean, these kind of went out with parachute pants and mohawks and things like that, although I see some of those things coming back now. But anyway, dial-up connections really just use plain old telephone service, also known as public switch telephone networks, and an analog modem. And I think you've all probably seen or heard these before. They make that awful squawking noise that fax machines make. They make the same kind of noises when a connection is being made. And what this does is it just uses amplitude, it just uses modular signals that come across the phone wire to make that connection. And modem stands for modulate and then demodulate. So it has to convert analog signals back to digital before it gets to the destination computer and actually inside of that destination computer. Because, of course, your computer really ultimately deals with digital data. But it would use this as a network connection. So instead of using a wireless network, or instead of using something like an Ethernet connection where you get fast speed and so forth, you'd be using these dial-up connections instead. And at the maximum, the standard was 56K was the maximum speed for a modem, although because of FCC regulations that was kind of capped at 53K, although I don't think I ever made a connection that fast. Most of the time you're in hotels where the signal you have to go through goes through a lot of switchboards and switching equipment and all this kind of stuff, which adds a lot of signal noise and things, and you usually wind up with maybe 16K speed or something like that. Very painfully slow. This has been largely replaced by virtual private networking, but let me just show you where you would get started if you did need to create one of these types of connections in Windows 7. First of all, you'd have to have a modem installed in the computer. Then you would have to go to connect to a network or set up a new connection or network. Since we don't have our modem connection made yet, I'm going to choose the top option there. And then what I want to do here is to set up a dial-up connection and then click Next. Here you would then enter in the phone number that your ISP, it says, gave you. This would be the case if you were using an older dial-up connection to the internet. That's still sometimes the case in difficult to reach areas that do not yet have broadband. Bradbond. I almost said Bradbond. Good thing I didn't. That would have been really embarrassing. Anyway, so if you don't have a good high-speed broadband connection, you might use modems. And this is how we used to connect to services like Juno and AOL and stuff like that, old methods. But you would enter in the number. So it'd be like 623, 555, the Hollywood number of 555, 5555. Okay? So that might be what we would be typing in here. And then we would get the username, and maybe a password, whatever that is. And then, by the way, I'm going to show you my password. Just because I trust you so much, I'm willing to let you see this. Okay, there it is. Actually, that was just me banging away on the keyboard there. So there you have it. Anyway, then we can remember the password if we want as well, and then give it a name. And then you can also then make a connection. And then that would be pretty much it for our current purposes, because I don't actually have a physical modem installed in the computer. I just kind of have a fake one that I installed, and you can do that by installing a legacy device from Device Manager. But here you also would have dialing rules that you may have to configure, and this would indicate whether or not you have to dial a 1 before you go out. Also whether or not it's a tone or a pulse, and some other self-explanatory items here, like what things you have to dial to get an outside line. Do you have to dial star 70 or, I don't know, one of those kinds of combinations or something like this. So that's how you make a dial-up connection. Now, before I move on to a VPN here, let's address both the purpose of a VPN and a dial-up connection. With either one, normally the reason you want to use them is to connect to a corporate network and be pretty much the same as if you were physically on that network. Although there may be a difference in speed, so that may not be on your gigabit E network, but you're on a broadband internet connection in the case of a VPN, or you might be on just a dial-up connection, connecting it at a blazing 16 kilobits per second. Either way, when you make these connections, you should then be able to do things such as browse your mapped network drives, check your email, and do a lot of the things that you normally would do if you were physically connected to the wired network in the office. But a dial-up, of course, has a lot of problems which I've already discussed. A virtual private network is definitely the way that most people do it now because, well, we already have an internet connection, so we might as well use that high-speed internet connection to gain access to our networks in a secure fashion. And that's what a VPN does, is it creates a secured tunnel. And you can kind of think of the tunnel as, an encrypted wall. So if this is my tunnel, it's like made of like an encrypted fabric or something like that, to protect the authentication and data over a public network. So it creates a tunnel through the internet, and the internet public, if they know how to look for it, they should be able to see that there is traffic there. But since it's all encrypted and everything, it's pretty much just meaningless to them. But in order to make this work, and the advantage here is going to be performance. It's much faster than dial-up modems. Then it's going to require that you have routing and remote access installed, NPS, which we just looked at a few minutes ago, and then a DHCP server or a static pool of addresses that you want to dole IP addresses out to your VPN clients, and then client-side configuration, which isn't too hard either. So let me show you a few things that we've got in place to make that work. And then over here on my server, I just wanted to show you what that would look like on the server. And again, you don't need to memorize this for our current exam purposes, but just to give you a little bit of a sense of context. Here you have routing and remote access. This is an additional item that you'll add to the roles. So you'll right-click here, choose Add Roles, and you'll have routing and remote access as one of the roles that you can add in. Once you've got it on here, though, it'll have a red down arrow on it. Like right now, you can see it's a green up arrow. That means I've configured it. If you haven't configured it, you'll need to right-click here and then choose Configure and Enable Routing and Remote Access. Having done that, then, you would also then have some policies that are part of NPS. We saw some network policies earlier when we were talking about DHCP and network access protection. Here you also see that we've got connections to Microsoft Routing and Remote Access Server. And you can double-click on this and say whether you want to grant access or not. I, of course, am granting access, so that's why we will then be able to create this connection. So I'm going to do that from some other computer. Let's go to this one. And you can see I'm in Control Panel on a Windows 7 workstation. What I need to do is to set up a new connection or network, since I have not yet set up a VPN here. I'll just go ahead and click on Next. And I want to use my existing internet connection to connect through the internet to that host. And I can do it by a fully qualified domain name if there's DNS services available to resolve that for me. I'm just going to enter in the IP address here in this case, though. And then you can also allow other people to use the connection. If you've got a smart card, which you talked about before, you can use that one as well. I'm just going to leave it the way it is for now and click on Next. Then I'll enter in the credentials for the user. And then we'll go ahead and just make a connection here. So we'll just click Connect. And it's going to verify the username and password against my domain controller in this case. And then it actually goes through several different steps. It's going to try to use Ike version 2, which I'll talk about in a little while. It's going to try to use SSTP, and both of those two methods are actually very secure and really good methods. If it can't do that, then it'll go down to using one of the final methods there. Let me close this up. And you'll see that right here if I go into the VPN connection that it's going to be using PPTP in this case. And I think we can see it here. Yeah, it's using PPTP, which is point-to-point tunneling protocol, and it's secure. It's okay. And it's probably one of the easiest ones to work with, but it's not as secure as a couple of those others that I mentioned. But now you can see what happens here is I could be in the airport on my laptop on their internet Wi-Fi. But because of the wireless, or rather because of the VPN connection that I just created, I've now created a tunnel back to my home office, and I can look at files on the file server. I can send a print job over there. I could download my email. I could browse the internet. I could do all kinds of things like this, and it's a pretty good method for making a connection back to your home office. I also want to point out a performance tip for you on this. I'm not sure this will really be on the exam anywhere particularly, but it's interesting to know and useful in a practical sense. And if I go to my VPN connection here, notice that if I go to the properties of it, and then networking, and then TCP/IP version 4, and finally back into properties here where there's an advanced button. Once I get into this, look at this checkbox right there where it says use default gateway on remote network. What's that about? Well, you see, now that I'm connected to my home network, it's going to route me to the internet the same as if I were actually seated in my cubicle in the office, which means that it's probably going to go through, when I try to resolve an address, it's going to go through that DNS server. It's going to go through one or more proxy servers. It's going to go back out through my DMZ and then back out to our existing ISP back in that office. What does this mean? This means then that my internet access might get really slow because I'm now using all of my internet access from that office. Now, I might be halfway around the world where I might have a broadband internet connection that I made to create this VPN connection in the first place. And I could get really good access if I could just continue on using my existing internet connection. But instead, I'm using the corporate internet. And since it has to go kind of in a roundabout way to get me back out to the internet, I might want to override that. And in order to do that, I would choose to deselect this item, which says Use Default Gateway on Remote Network. Now what will happen is I'll still have access to my internal resources in the corporate network, but I'll use my existing internet connection that I had when I made this VPN connection, and I'll use the ISP's DNS servers, and I'll use their network equipment of all different types and so forth. And you're going to find that you have a much better experience from the user side of things in terms of the internet performance. Now, when you make these connections, you don't always have to go to Control Panel. Normally, they're going to be down here, and you can see that I'm currently connected to VPN. Now, I'll just go ahead and quickly disconnect. But if I wanted to make a connection again in the future, I could again click on that same little item there. There's the VPN connection, and then connect. You can enter in credentials, and you can save those if you want to, if you feel some level of assurance that other people will not be using the same computer to log on under your credentials. So that's pretty much it in terms of making these VPN connections. The only other thing we have with Windows 7 is that there's a new feature now that's a really cool item. It's called Direct Access. That doesn't seem right. It seems like I'm forgetting. Oh, I am forgetting something. Sorry. I meant to show you this document first. Here, let me go back over here. This is the thing I created for you. This is on VPN protocols, because you heard me mention a few different kind of acronyms and stuff like that. PPTP, which is the connection that I made. I talked about Ike version 2 and so forth. Well, PPTP is point-to-point tunneling protocol, and this document's available for you on nuggetlab.com. It uses the following types of authentication. Anything that has the word CHAP in it, like this one here, is a password-based authentication model. This is not generally considered very secure. You're better off to use the version 2 because it takes additional security measures to protect the password there. And then EAP is Extensible Authentication Protocol, or Protected Extensible Authentication Protocol, which we'll look at here in a little while. It shows that it does give you security in terms of confidentiality, meaning that nobody can see the payload of the data that's being transmitted back and forth, and it uses the Microsoft point-to-point encryption protocol to do that. This is secure enough for most general purposes, but of all the different types we have, it's still the least secure. There's many better options. It's most compatible, most common and most compatible as well, and it's easy to configure because primarily it can use username and password authentication, whereas some of these other methods, I guess actually all of these, will use certificate-based security. So like L2TP, which is Layer 2 Tunneling Protocol, this one will use a certificate-based IPsec for authentication, and using IPsec provides for you integrity, meaning that you can be sure that the packets have not been changed in transit, encryption, which means that they're just that, encrypted and protected, and also confidentiality, meaning that your password is not in plain text either. There's also something that's used here is going to primarily be computer certs and that are going to be required, and this works with IP version 4 and IP version 6. There's also SSTP. This was new with Windows Vista, and this is actually pretty good because it uses SSL. This means that we don't have to open up additional firewall ports, whereas these other methods, like especially L2TP, you got to open up quite a few ports to make that work because there's a lot of moving parts with it. This is using SSL, and most corporations already have 443 open through their firewall, so that's going to be fine there. And it's going to be more compatible with firewalls, NATs, network address translation, proxy servers, and that sort of thing, because some of these other VPN solutions really have trouble with NAT servers, for example. They just have trouble translating the addresses in and out of the network. And then Windows Server 2008, Vista, and Windows 7 is compatible with all of those different operating systems. And the client then must also trust the certificate that appears on the RAS server, so it needs to be a certificate that was issued in most cases from either a public certification authority or from an internal Active Directory CA, such as an enterprise CA, because any of those certificate authorities will automatically be trusted by the domain clients. And then there's Internet Key Exchange version 2, and this uses again a number of the common protocols we've already taken a look at there, but this is something that only Windows 7 supports. And the reason why IKE version 2 is actually pretty good is because it supports VPN Reconnect. One of the troubles you'll find with remote users is that they will be in the airport and they start to check their email or start a file download, and then their flight is called and they just close the laptop lid, it goes to sleep, and they get on the airplane. Well, then when they reconnect a couple of hours later back in a destination, what happens to that file that started to get downloaded and stuff like that? Well, it somewhat depends upon the method that was used for download, but with IKE version 2, the VPN Reconnect, it will just automatically reconnect and resume whatever was going on with the network traffic at the time the disconnection took place. Whereas all of these other methods, you would have to start all over again. Okay, so that's a big advantage of IKE version 2, but it requires a little bit of infrastructure preparation as well. The authentication protocols are what we see down here. I'm not going to exhaust those, but those are something you can read through as well in this document. Okay, now I'm ready for direct access. I knew I was forgetting something. Now, direct access is probably the best of all the VPN solutions. It does require some infrastructure in order for you to be able to set it up, but once you got it going, it is really a cool way of making VPN connections. And the reason why is, well, you don't really make a VPN connection. It's just always there. It's an always-on VPN connection. If it detects that the client computer has an internet connection at all, it'll just immediately build that VPN connection without any user intervention whatsoever. You configure this so that it can also work with NAP if you want to, so people have their antivirus updates and whatnot. And it's an IP version 6 type of a connection, so that's important to know. This is something that will also use IP6 transition technologies, such as Teredo servers, to help get you there, in case you have to traverse an IP version 4 network somewhere. This only works with Windows 7 Enterprise and Ultimate editions. Okay, Nothing else. Only Windows 7 Enterprise and Ultimate. And the computer must belong to a specific group that you'll create. And if the computer is a member of that group, it will have access through Direct Access, provided everything else is configured properly. By the way, all the client configuration is all this stuff right down here at the bottom. And the other thing you'll do is you'll configure this through a group policy object and enable that for any clients that receive the GPO. The client certificate does have to be there as well. So a good way to work with that is, if you can do so, is to use auto enrollment so that it will automatically issue a certificate to any of your clients that you want to have direct access. And many of your computers will already have automatically issued certificates because you may need them for other purposes. And then as far as those actual settings that you'll need on your Direct Access client, I put that at the end of this document that I showed you earlier. Here's the configuring Direct Access via GPO settings. You actually have two ways of doing this, GPO or NetShell. GPO is probably going to be the preferred method because it's going to apply across a broad scope, whereas NetShell you have to do locally on each individual client computer, and it's probably not practical. So you'll configure the group policy objects in these following locations. Okay, and then you'll just see some different translations here. You can identify which servers are going to handle 6 to 4, for example, where your Teredo servers are. And you can also identify the public IP addresses of your Direct Access server in the 624 relay name. What you're going to have here, as I'll show you in a little while, is you'll have 2 consecutive public IP version 4 addresses on the internet-facing interface for the Direct Access server. And then the group policy object settings that you can work with, let me expand this out a little bit, I'll show to you. These would be under Windows settings, and then you'll see a network item under here called Name Resolution Policy. And within this, we'll just go ahead and specify this tab here, DNS Settings for Direct Access. Then you'll just enable this, and you'll click Add to enter in the DNS server right here that is going to resolve for you in Direct Access. So that's one of the settings you'll need. And then the other one that you're going to need will be found under here, under Computer Configuration, Administrative Templates, Windows Components. Then you'll go down to, actually you won't be here, sorry. You'll be under Network, and then TCP/IP settings. That's where we'll need to be. And then our IP version 6 transition technologies. And we discussed what a lot of these were in a previous nugget. But in particular, what you'll need to do is configure these items that I list for you here on the group policy object. Now, if you do not want to work with the group policy object for whatever reason, you can configure them locally, just again using the NetShell commands, and I give you the syntax and everything you'll need to type in right here. And then for the server side of this, you're going to need to have Windows Server 2008 R2 only. You'll have 2 network adapters in this. One of the network adapters is going to have public addresses on it, so it's going to have 2 consecutive public IP version 4 addresses on it, and then the other one will be just a private one connected to your internal network. And that's common with any VPN, regardless of whether you're using Direct Access or something else. One of them will connect to the internet, and the other network adapter will connect to the private network. Then you'll also have a server authentication certificate, and as always, you need to make sure that the certificate there matches exactly the fully qualified domain name that is going to be configured upon your clients. And then for the server, the other thing you'll do is you'll go into Features here, and you'll add in Direct Access, which you can see I've already added in here. This does require that you can't really proceed with this unless you have 2 network cards installed, and one of the network cards has 2 public IP addresses bound to it, and you'll have to do that through the advanced properties of your TCP/IP version 4 properties. And then once that's been done, you can step your way through this interface. It's actually kind of handy the way they do this. So you just click on Configure, for example, to add any computer accounts that you want to be the member of a specific group that will be granted access to Direct Access. And you can make that usually a pretty broad group. And then you'll configure the Direct Access server itself. You have to, as it explains here, this will identify some security policies that are going to be necessary for authentication as well in some of this. And then you'll identify the other infrastructure servers you'll need to have, such as the DNS server that can resolve the names for you. And then you'll also identify any application servers that you want to make available to the clients that make these connections. And that, for the server side, at least, is the broad stroke of what you'll need for a lot of these Direct Access configurations. Now let's conclude here with a discussion of remote desktop services. Now, some of you might look at that and say, James, you're getting old and senile. You forgot that you already discussed this. Well, folks, I remember that I already discussed this, but this is a slightly different topic, and thank you for thinking so nicely of me that I'm getting old and everything. Gosh, absent-minded. All right, what were we talking about then? Remote desktop services here. Okay, what this does is it actually replaces something else that we used to have in Windows called Terminal Server. Now, the difference here really is that in the previous discussion I had on remote desktop, that's where you have a single computer here, and you're trying to connect to another single computer here. Okay, and this could be, a Windows 7 computer here to another Windows 7 computer, and it's for productivity purposes. This one's in the office, and you just forgot to fill out a report, so you connect from home. Okay, that's a one-to-one connection where only one connection is allowed at a time. But remote desktop services is the key word there. Services is something that you install on a Windows Server 2008 server, and this is where you can have virtually limitless connections to that remote desktop services server within the limitations of how much memory and hard drive space and network bandwidth it can tolerate. Now you might be thinking, why would you have something like this? Well, if I do this and I install a set of applications on that terminal server that the users can use, then I only have to install it and maintain it one time, as opposed to installing that application on every individual user's desktop. So that's one reason why. It's very simple to manage in that respect. Another reason there would be that we can have users on older hardware connecting to the terminal server. I mean, we might not be able to afford to upgrade everybody to the latest processors and 8 gigs of RAM or whatever, even 4 gigs or 2 gigs of RAM. Some of my clients might only have a gigabyte of RAM in them, and so they can't even take an upgrade to the most recent version of Windows, at least, and perform it well. But if we just make sure that they have a remote desktop client that they can use to make the connection to my remote desktop services server, then I can give them all the benefits of a current Windows operating system with very little, if any, of the hardware costs. And so a big part of that is the centralization and the minimal expense involved with it. Although, of course, you also have to pay a premium for the licensing of Terminal Server. But overall, it should still be cheaper than buying everybody brand new computers. With remote desktop, you're going to have a remote desktop to the server, and that, as I mentioned earlier, allows many connections. So whereas this was a one-to-one connection, if you were to instead, have an older client, maybe it's a Windows XP client here, Windows XP. Okay, kind of messy, I know. And then you had a server here. Well, you can have this one user connecting here, and then you can have another user connecting from here, and another user, and another user. You might have a couple hundred connections if the server is able to handle that in terms of the hardware. Also, you might have something involved. You don't have to have this, but you might have something there called Remote Desktop Gateway. And for that one, let me just show you an example of what this is useful for. It's going to be where you can connect, for example, via the internet, and you do not have to establish first a virtual private network, because sometimes that's how, or actually very often, that's how clients are connecting, because they know they need to connect to the remote desktop services server, but they don't have a way to get connected because that server's not directly on the internet. So what they'll do instead is they'll create a VPN connection, then they'll make that connection. Then they'll open up the remote desktop client piece, then they'll make that connection. And they may have to enter in credentials for each one of those items. And then finally they're connected. Well, what we can do instead with Remote Desktop Gateway is we can just use this and use SSL, or Secure Sockets Layer. That operates on port 443, TCP 443, and that's very often already open port on the firewall. As a result, also, we don't have to open up the additional port for 3389 or figure out some tricky way to use a different port than the conventional port 3389 and try to hopefully fool the hackers into not knowing that we're on that port for remote desktop. So with 443, it's already intrinsically secure if you also implement the right certificate authorities, and it's a really good way to make a connection without having to jump through a lot of hoops. The way this works here would be that you'd have a client out here, and they will connect to, say, a border network. This is just a network that's on the outside of my own infrastructure here. This is where my perimeter network is also known as a DMZ or demilitarized zone. And I'll have Terminal Services Gateway here. This Terminal Services Gateway knows where my actual terminal server farm is. So it'll take over SSL or port 443 here, it'll take that inbound connection attempt and it will go through any other services that it needs. I actually created this illustration for a Windows Server 2008 topic, so it's got some more stuff in there than we need. But basically the idea here is it'll use Active Directory, and it can also be subject to network access protection and internet authentication services, and it can take all of these things and ultimately connect you to a terminal server farm, all without you having to create a VPN connection and connect that way or do anything else elaborate. So it's very easy in terms of the user's configuration there. And then let me also show you something else here. If I go to a remote desktop connection, I'll bring one over here. If I go to the options of this, from the client side, this is where this would be configured. Will be on the Advanced tab and then on Settings. And from here, you can automatically detect Remote Desktop Gateway Server settings, and it'll just probe for anything out there that looks like it's a remote desktop gateway. Or you can use a specific remote desktop name, remote desktop 1 dot, nuggetlab.com or whatever else it is. Okay, so those are the options you can use there in the client piece of making this connection. And then I want to show you another really cool thing there, and that's something called Remote App. Now, Remote App allows us to make a remote connection to a destination computer, but instead of getting the entire desktop like you normally do with remote desktop services, you only get a single application. Now here I've just temporarily installed Remote App Manager here and Remote Desktop Services on one of my servers. And what I'll do here is I want to show you how this works. If I scroll on down here, you're going to see that I've already got an application that I've installed. What I did was I just ran the MSI file that installs a utility that you can download from Microsoft called Calc Plus. I think it gives you, additional features that are just, it looks like a Fred Flintstone kind of a calculator or something like that. I think they actually created this at Microsoft at the request of Bill Gates, because the default calculator that is included with Windows was not powerful enough to calculate Bill Gates' fortune. So they had to come up with this thing, which goes extra digits or something like that, and it goes into the gazillions of numbers. Anyway, so this application, I went ahead and installed it, and we're running it locally on this server right now. Okay, so there's the item right there, and I can just double click on it. And there it goes. Okay, nothing special about this. Same thing that you would have on your own desktop if you decided to install it. However, now that it's installed on my terminal server, rather my remote desktop services server, which is what this is, then I can also make it available down here. And the way you do this is you just simply right-click here and you add remote apps, and then you just next your way through the wizard, and then you just look for whichever other application it is that you want people to use. Maybe a Acrobat Reader, something like that. So I'll just next and finish. And now you can see I've got a couple of applications available there. Then what I will do here is I will create either an RDP file, which I make available to the users either through some kind of shortcut, and you can create a shortcut on the user's desktop through group policy or something that points to this, or I could create an MSI file, and using SCCM or System Center Configuration Manager or group policy objects, I can install applications for users as well. So I might create an installer package. I already did that for Calc Plus, and let me show you where that landed. Went right here. Okay, so it's in my C drive, program files, and then packaged programs here. This is just an MSI installer that if I were to double click on it on the client side, it would create a link to the application back to this remote desktop services item. Okay, let's go ahead and see how this works. I actually just put this on my own desktop. I took the MSI file that I just created. I double clicked on it on my own desktop, and then it created this calcplus.exe item. You can specify when you create this MSI whether you want it to create a desktop shortcut, which I specified I wanted, and whether or not it appears on the start menu, which I also specified I wanted. By the way, this in the background is just a photograph I took of, I think that's Mount Moran in the Grand Tetons when I was up there this past autumn. So yeah, this is my own personal desktop, and I'm clearly not on that server right now. I'm on my own desktop. So now when I double click on calcplus.exe, you may get a prompt, okay, if there's no signature there that can identify it, but that's okay. We'll just click on connect. And then you may also have a prompt for credentials. And I'm typing those in off screen over here. And then You may get this prompt right here that says it's just being run from somewhere remotely, so that's okay. Well, let's go ahead and run that, and then that's pretty much it. We'll get the application. Actually, let me drag it over because it went on the wrong screen. There it goes. So now we have the application, and it looks as if it's installed and being run locally. There's no way to tell visually that this is actually being run from a remote server somewhere. Oh, by the way, this is not actually what they used to calculate Bill Gates' wealth. This is what they used to calculate my wealth, and you can see here that it already has the answer pre-provided. Don't even have to type anything in. It's automatic. Okay, so that's how you work with Remote App. In this nugget, we took a look at remote access. And remember, we started off by talking about network access protection, which is where someone who's unprotected might enter into your network and potentially threaten it with some kind of a security vulnerability. Well, network access protection will put them in that quarantined network or remediation network until everything's fixed properly, and then they can get back on the unrestricted network. We talked about dial-up connections, which certainly are very slow and antiquated, but you may have to use them some places, so I went ahead and showed you some of the basics of it at least. Of course, virtual private networks are much more common, and they're also a secure way to connect over an insecure network, such as the internet. Direct access is a new type of a VPN, and this is a great way to fully automate the connection to your virtual private network. In fact, the client doesn't actually have to do anything. This is all done automatic. Remote desktop services is also a way that we can provide for ourselves a desktop to users. Even if they don't have capable hardware to do a full installation of Windows 7, they may still be able to use remote desktop services to connect to a Windows Server 2008 server and still get the full experience of a desktop. Also, you can use Remote App, as I just showed you, to be able to deliver applications to the user without having to install the actual application on their computer. Well, I hope this has been informative for you, and I'd like to thank you for viewing.